but that's the orbital plane, okay? I'll just set this right here. Then the shuttle has two little booster rockets inside with the fuel on board here, and this kick it into the final orbital velocity of 17,500 miles an hour. Obviously, that's only about 100 miles difference. If you don't get to that velocity, the shuttle will come back along with the booster, with a tank. Anyway, the tank is the only part of the shuttle that is not reused. So every time they launch a shuttle, they have to build a new tank. Okay? So that's the launch. Then we get into, now we have to transform into the space mode. And here is a picture of the shuttle, any way you want to look at it. And it has to open the cargo bay doors. The reason for that, that's part of the air conditioning. That's part of the system that we provide for Hamilton. These doors here are covered with piping with Freon. Oh, we take Freon to space. Is that bad?
Yes.
How bad is it? Very bad. What we do though, the system that we build has to go through and we check with a mass spectrometer to make sure it don't leak. We actually check we pump the system full of helium first, and we count the helium molecules coming out of it. If it don't leak helium, the mass spectrometer, it ain't going to leak Freon. Now what happens when there's a car accident out in front here and you have a front end collision? All that Freon in your air conditioning system, where does it go? Okay, so NASA does not leak Freon unless you have a problem, okay? Now, so the shuttle that has to fly, it can fly upside down. It can fly anywhere it wants to. Let's see if I have my little thing here. Okay, here is the... Oh, that's a pen. It works. Here's the cargo bay. This here is the pressurized crew compartment. It's pressurized to 14.7 pounds per square inch, 1 atmosphere of nitrogen and oxygen. All the Apollo stuff, over here I'll show you the Apollo stuff later on, the lunar module, that was all with 5 pounds per square inch, of roughly 1/3 of an atmosphere of pure oxygen. Can you breathe pure oxygen? Yes, you can. The body lives on the partial pressure of oxygen at 1 atmosphere. If you take away, you got 80% of nitrogen and 20% of oxygen. If you take away the nitrogen component, your body is still, because the nitrogen just goes through the ride, comes right back out again. So your body lives at the partial pressure of oxygen. So therefore, if we build systems lighter back in the early days, they were lighter, less complicated, but they were more dangerous. So they made the shuttle a heavier compartment with proper oxygen and nitrogen, and now you live in an Earth environment, properly temperature controlled. We remove the humidity and all that kind of stuff. It's not as warm as it is right now. Right now we've got 82 degrees, about 80 degrees right over here. Okay? So that's the shuttle. And now the shuttle basically, we can stay up there inside. 7 astronauts live inside the shuttle. There is no sink. There is no shower. There is no refrigerator. There is no mom and dad and no gravity. What's the best thing? No mom and dad? Okay, what's your name? Gregory? Well, now, what's the problem? Basically, who cleans the bathroom? There's no mom and dad. So you go home tonight and do some early astronaut training. You help your mom and dad clean the bathroom, okay? But we have I'll talk, Dr. Flush will tell you the details later, okay? We have a neat machine on board, okay? Anyway, so since inside the shuttle, you live in your street clothes. You don't live in the spacesuit. The spacesuit is only used when you go out for a spacewalk. Okay, that's news, right? However, you see that when they do launch, though, they go as a result of the result of the Challenger. What happened is, if you'll notice the machinery here, when the tank blew up on the Challenger, okay, 55 million horsepower blew the whole thing. Okay, the cabin up here basically was blown free of the explosion. This is the serious part here now. This part was blown free of the explosion. Went up to 65,000 feet, trailing pipes and wires. 2 of the astronauts had changed over to manual oxygen, like a pilot in a jet plane. At that time, all they had was a face mask for oxygen. Okay? Anyway, what happened, this cockpit was compromised because of pressure. All 7 astronauts, after a 2.5-minute free fall, died of blunt trauma when they hit the ocean. So what did NASA do? They said maybe there was a possibility to bail out. So 2.5 years later, they finally flew the shuttle again. But now every time you see the astronauts go in the shuttle, they come out with this orange flight suit. That's made by David Clark up in Worcester, Mass. That is a flight suit. It's got a parachute in it. It's got survival gear, and they use that only during the launch and reentry. So the NASA has won the extra mile. When you fly a 727, do you fly with a parachute? So basically, NASA's a little bit, they try to provide you with enough safety. Also, as engineering, what we do is, when we build a piece of hardware, like the rocket system or the heat exchangers or whatever, we have to predict a possible failure. What's a failure in your Dodge? Flat tire? I don't know if you have a Dodge or not. A flat tire is identified failure, right? What's the corrective action? Call AAA or change it. All I'm trying to say, for every system that we make, we have thought up of all the possible failures of our specific system as engineering. We send all these to NASA. NASA adds up all these possible failures of a shuttle. Every time a shuttle flies, there are some 3 million identified possible failures and corrective action. Obviously, there are a couple that are not there. Okay, so we do our homework. We try to do our homework. Shuttle can stay in space for about 17 days. The limitations are liquid oxygen, liquid hydrogen, liquid nitrogen because of the cryogenic systems on board. Shuttle cannot go to the moon. Okay, it's limited by other thermal reasons too. Shuttle basically then has to come back. It has to close the cargo bay doors. You got 2 retro rockets. You slow down over Australia, coming east. And then basically it takes about a half an hour, 45 minutes to slow down enough from 17,500 miles an hour. You fall back in. This is the heat shield. And that protects you from basically the systems in space. The reentry heat. Here is one of the shuttle. Later on you can come up and feel it, but it's very, very light. Just touch it gently, but there are 24,000 glued to the bottom of the shuttle. The outside is black carbon. The inside is cast silica sand. If you do a microsection and look at it under a microscope, it looks like you're looking through cobwebs. You can heat this up cherry red and put your hand on the bottom. When the shuttle comes in, this surface can probably approach 2,000, 3,000 degrees because of the plasma of the heat of reentry. Now, obviously, some of these have failed, and it's not the one they had on the Challenger was the leading edge of the wing. The last time you may have heard they had a possible failure, they did have a gouge on this. These things can get damaged and still provide proper protection. Okay? Very, very important material.
That's not ablative in any way, is it?
No. When they go back to the Orion, they will probably go back to ablative. The Mercury, Gemini, and the Apollo were all ablative reentry. It heats up, it gets hot, and the hot material melts and goes away. This is a totally insulative system. Okay, that's pretty much the shuttle. Any questions on the shuttle? Yes?
How many tiles would it take to cause a failure?
How many tiles would it cause a failure?
Depending on where it is, or just...
When the Columbia first flew back in 1981, they lost about 100 tiles.
Wow.
Now, every time the shuttle comes back, they take it into the hangar down at Cape Kennedy, and they pull a vacuum on each one of these things. Also, there was one of the shuttles was on a launch one time, and before the launch came, a thunderstorm came through, and about 100 tiles were damaged by hail. So they had to take them all off again, the ones. All I'm trying to say is it depends where it is. If it fails on the bottom, that's the most critical, towards the leading edge. Case in point, one time they do dump water. Okay, what I'm trying to say about UTC, United Technologies, they provide fuel cells. The electrical energy for the shuttle are 3 fuel cells. You put oxygen and nitrogen, oxygen and hydrogen together safely, you get electricity and water. Actually, they have so much water on board the shuttle, they have to dump it out a little nozzle. Okay? Well, one of these nozzles was pointed